As you are coming in, just need to say I. So we're looking at complex number. What is complex number? Complex number has this form. Uh, it has this form. Okay, A plus BI, where the A is the real part, where the part that has the I, which we call this part, the part that has the I is called the imaginary part. Okay, so complex number is a combination of the real parts and what? And imaginary parts. Combinations of what? Real parts and imaginary parts. The question now is that what is the meaning of the I? When we were small, we believed that square root of -1 is not possible, that you cannot solve it. Square root of -1 is equal to complex number, is equal to I. Okay, so complex number is what? A combination of real parts and the part that has the I. Okay, and that part is called imaginary parts. I'm going to start from these square root of -1. Square root of -1 giving us what? Giving us this I. If you square both sides, take a square of this, square this one also. If you square a square root, the square root will disappear and you're going to have -1. So we're able to establish that I squared is equal to what? -1. I squared is equal to what? -1. So we're going to be making a reference to this form. Okay, I square of I is equal to what? -1. As you're coming in, just begin to say I. If this is your first time, please subscribe and begin to share the links across your different platforms. -36 in terms of I. In terms of I. Okay, so root -36 is equal to root 36 times -1. And according to sort, root AB, A times B is equal to root A times what? Root B. So this will be equal to what? Root 36 times what? Times root -1 times root -1. And that will be 6. And this one is what? Is the R. Is R. Okay? That's that on that case. Let's take another one. Root -28 will be equal to what? Will be equal to square root of 28 times -1. And that will be equal to what? Root 28 times root -1. Okay? And root 28, we're going to make it in two parts, such that one of the parts has a perfect square. So root 28 is 4 times 7. Okay? 4 times 7. And that will be equal to what? 2 root 7. Okay? For root 28. And then times what? This one is what? This one is equal to I. And that will be what? You can place the I by the side, or we'll make it 2I root 7. Solve the equation. We have x squared plus 9. And that will be equal to, we're going to make the s squared as the subject. So that will be s squared equal to what? -9. Okay? And then take the square root of both sides. And that will be equal to what? This equal to what? Plus or minus root -9. Okay? And that will give us plus or minus root 9 times -1. And that's equal to plus or minus root 9 times root -1. And that's equal to plus or minus, the root of 9 is 3. The root of this will give us a complex number. That will be I. Okay? So that's that on that. Okay? Let's see the second one. Solve the equation. X squared plus 6x plus 25. Let's see that one also. So this is a quadratic equation. This is a quadratic equation. Okay, we can use quadratic formula to solve it, or we can use the completing the square method to solve it. So I'm going to use completing the square using the completing the square method. Okay, and that will be equal to, I'm going to move this constant to the other side, and that will be x squared plus 6x equal to minus 25. Okay, then after that, I'm going to add the half of this, the square of the half of the coefficient of x to both sides. So plus half of 6 is 3. Okay, square of that plus what? Minus 25 plus what? 3 squared. So whatever you do to the one part must be done to the other parts. Okay, and this will form a perfect square. This will form a perfect square, and that will be x plus what? X plus 3 squared. You take the first one and the last one, add them together, and this will be equal to what? 25 plus 9, and that's what? That's 16. That's 16. Is that 16? 25, 9. Yeah, that's 16. Then you take the square root of both sides, and that will be what? X plus 3 equal to plus or minus root 16. And that's what? Root 16. Don't forget, this one will be minus 16. This is minus 16. This is minus 16. Okay. And that will be what? Plus or minus minus 16. Square root of minus 16. Okay. And the moment you take the square root, this is going to generate plus or minus. Okay. And this will be equal to what? Make the x the subject, and you're going to have minus 3 plus or minus. This one will give you 4i. This is equal to root 16 times what? Times minus 1. Okay, so that's that on that one. Okay, the next thing we want to go to now is to see the how to additions and subtractions of complex number. How do we add or how do we subtract two complex number, or even more than two complex numbers? So that's what we do now: addition and subtractions of complex number. They're just coming in, just begin to say I and begin to like, share, and subscribe. Okay. For example, let's say you have z1 is equal to a plus bi. Okay, and then you have z2 equal to let's give it 2a plus 2bi, and you want to add z1 plus z2 together. So when we are doing addition or subtractions of two complex number, what you do is to add the real part together, the real part of the z1 plus the real part of the z2, and that will be a plus 2a. Okay, plus you also do that for the imaginary part. The imaginary part is the part that has I. Okay, and that will be what? I is there. You can factorize that. B plus 2b, and that's b plus 2b, and that will give you 3i plus 3bi. So this is your real part, and this is the imaginary part. Okay, the attachment to your I is your imaginary part. So that's the real part, imaginary part. Okay, and at the same time, you can also find the z1 minus z2, the subtraction. You can find the z1 minus z2. z1 minus z1 minus z2 will be equal to a plus bi minus, they're going to open the brackets because the z2 is an expression. It's not a one item. So that will be 2a plus what? Plus 2bi. And then the next thing to do is to open the brackets. And that will be a plus bi minus times this, that's minus 2a, minus times a plus, minus, and that will be what? 2bi. And then you begin to add the real parts. A minus 2a, that's a minus a, and then minus the imaginary part plus bi minus 2bi. Okay, you can make it more easy for you by factorizing. This is here bi minus 2bi. Okay, you can take the this is a plus plus. We can take the I out, and that will be b minus what? B minus 2b. You can take the the I out. I is there. I is there. Take it out and factorize the I. Okay, and that will be b minus 2b. Okay, so in a nutshell, finally for this one, it's going to give us a minus a minus b I. So that's that on the additions and subtraction of complex number. So let's go to typical examples. We have here is 2 plus 5i plus 7 plus 3i. Okay, so this is addition of two complex number. So it's going to be, you can open the brackets, that will be 2 plus, begin to add the real part. This is the real part, this is the real part. 2 plus 7, and then plus 5i, 5i plus 3i, and that will give you 9 plus 8i. Okay, that was the first one. The second one, we have 7 minus 4i minus 5 plus 6i. Okay, so what we do in this case is to open the brackets. Okay, this minus is going to alter the sign inside the brackets. Minus times minus, that's a plus 5. Minus times a plus, that's a minus 6i. Okay, then we can now bring the what? The real parts together. The one without the I, we can bring them together. And the one with I, minus 4i, minus 6i. Okay, and this will be what? This will be 12. These two, if we like, we can take the I out, but there's no need to do that. What you are doing is the coefficient of the I that you are subtracting. Minus 4, minus 6, that's a minus 10, 10i. And that finish that second one. Okay, let's see the third one. 2 plus 2i, and then minus 2 minus 3i. Okay, that's the third one. So this will be equal to what? Open the brackets. Open the brackets. Minus 2 times this. Okay, when you have minus outside an expression of a bracket, it's going to alter the sign inside, and that will be minus 2 minus times minus, that's a plus 3i. Okay, minus 2 plus 2 cancel. Then you have 2i plus 3i, and that's a 5i for the third one. Okay, for the fourth one, number 4, the one we have here. Okay, let's do for space. The fourth one, we have 1 plus 8i. Okay, minus 6 plus I. Okay, that's what we have there. What we are going to do is to open the brackets. Okay, minus, let it comes in, the minus 6 minus I, and then begin to add the real part together, the imaginary part together. 1 minus 6, that's a minus 5, plus 8i minus I. Okay, what you are doing there is just the coefficient. This is the coefficient of I in this place is plus 8. The coefficient of I in this place is minus 1. So 8 minus 1, that's what? Plus 7i. And that finished that fourth one. Okay, that finished that. And finally, the fifth one. The one we have there, do the same thing also. Open the brackets. And then 5 times this one, that's minus 5. Minus 5i plus I. Okay, minus 5 plus I. Minus 5 plus I. Okay, minus 5I. So that will give you minus 4, minus 4I. So that's that on the addition and subtraction of complex number. The next thing to do now is to look at the multiplication. Multiplication in complex number. How to multiply two complex number. Okay, we're looking at multiplications in complex number. We're looking at the conjugates and divisions of two complex number and lot more with lot of questions. If you're just coming in, I want to say you're in the right place. Begin to what? Call your friends, your classmates to join us for this live section. And begin to say as you are coming in. Type your own question. If there is anyone, put it on the comment section. Okay, begin to call all your friends to join us for this live session. Let's go on to the multiplications of two complex number. The first one, let's have a little intro for the multiplication. Let's say you have Z1 equal to A plus BI. As I said at the beginning, you're going to have this is the real part. This one that contains the I is called the imaginary parts. Okay, so that's your the complex number. Let's call it A1. Let's call this one B1. And you have Z2 equal to what? A2 plus what? Plus B2I. And you want to multiply the two complex number. Okay, so how do you do that? That will be Z1 times Z2. Okay, and that will be equal to what? Let's put them together. A1 plus B1I times A2 plus B2I. Okay, and what we are doing is very simple, just normal expansion. Take this first one, A1, times the whole of these brackets, A2 plus B2I. Okay, and then plus the second one here, B1I times A2 plus B2I. I'm using this first bracket to do the expansion. And vice versa, you can do the second one also to do your expansion. Okay, and this will be equal to what? This one times this one, that will be A1, A2. This one times this one, that will be what? Plus A1, B2I. Okay, and then plus this one times this one, that will be A2, B1I. And finally, that will be what? B1 times a B2, that's a B1, B2, I times I, that will be I squared. Okay, so on the final notes, you can quickly say note I squared is minus 1. I squared is minus 1. And how do we get that? We got it from here. When we are young, we will ask us what is square root of minus 1. We say it is impossible. Okay, there is no impossible. And then when we go to advanced class, we have been told that square root of minus 1 is what? Is I. Okay, and then you can square the two sides, square this one, and when you square, when you take the square root of minus 1, the square root will disappear, will vanish. Then you have minus 1 equal to what? Equal to I squared. So I squared is equal to what? Minus 1. Is that clear? If there's any question, just put in the comment section. We're going to look at that and then we'll discuss that together. Okay, as you are coming in, just begin to say I. As you are coming in, just begin to say I. And if you are fresh on this channel, please subscribe right now. Okay, subscribe, like, and share. Like, share, and subscribe. Let me say it again. Like, share, and subscribe. So that's that. Then the expression here is going to change. That will be equal to what? A1, A2. The one that have I square here will now become minus B1, B2. And then this one, we can factorize the I. We can take it out. And that will be equal to what? A1, B2 plus what? Plus A2, B1. Okay, and that's the rudiments. That's the rudiment for the multiplications of two complex number. Okay, that is how to do your multiplications of two complex number. If this is not clear, just relax. We have a lot of questions to back up what we just did now. Okay, relax for more questions. Okay, no, in this channel, we used to play with more questions. Okay, and then the more questions you have, the better understanding. Okay, put your question in the comment section. As you know, we attend to those questions. Okay, begin to type your questions on complex number. Okay, maybe on calculus, on differentiation, just put the questions on the comment section. Okay, so let's now go into detail now into multiplications of two complex number. Plus 3i equal to, take this one, 4 plus 5i plus 3i times what? 4 plus what? Okay, and then begin to do the expansion. 2 times 4, begin to do the expansion, 2 times 4, that's 8, 2 times 5i, that's 10 I, plus 3i times 4, that's 12i, plus this one, and then I times I, that's I squared. Okay, then we're going to have now 8 plus 10i plus 12i. This I square, as we know, is minus 1, and that turned that place to 15. So then begin to add the real part together. That's 8 minus 15, and then the imaginary part, take the I out. That's 10 plus 12. You can factorize this one by taking the complex number out, the I, by taking it out. So you have minus 7, 1, 7, 7 minus 4i squared. Okay, I can do it in two ways. I will start from the rudiments. This implies 7 minus 4i times 7 minus 4i. That is the meaning of this expression. Okay, and that will be equal to this one times this one. That's 49. This one again times this one. That's minus 28i. And again, this one times this one. That's also minus 28i. And finally, this one again times this one. Minus 4i times minus 4i. And that's what? That's a plus. Minus times minus. That's a plus. This will give us a 4i squared. Okay, and this will be equal to 49 minus 28 minus 28. That's minus 56i. And this one will give us what? Minus 16. Because 4i implies 4i squared implies 4 squared and then I squared. And I squared is minus 1. Okay? So we now have 49 minus 16 minus 56i. So 49 minus 16. Okay, that's 33 minus 56i. And that finished that. If you want to do it in the fastest way, okay, is for you to know, note that when you have a minus b square, it's going to give you a square minus 2, I call it invisible 2, times ab. The first one, the second one, that's ab, and then plus the last one, square that. So I'm going to use the knowledge of this identity, of this algebra, to solve it now. So 7 minus 4i squared will be equal to a squared. In this case, my a is 7 minus 2, which I call invisible 2, and then a times b, that's 4, times 4i. I mean, your a is 7, your b is 4i. And finally, plus what? B squared, which is a minus, which is 4i squared. Okay, and this will be 49 minus 2 times 4, that's 14. 14 times 4, that's 56. Okay, and then this one, that'll be minus 16, minus 16. Okay, don't forget your I in this place, and that'll be 49 minus 16, that'll be 33 minus what? 56. So whichever way that suits you, you can apply that. So that starts on the multiplication of two complex number. We have 2 minus 3i times 4 minus 5i, and then times 1 plus 3i. What we are going to do, we are going to do the first two. We're going to multiply the first two. Whatever we now get, we now use it to multiply the third one. So the first two, 2 minus 3i times 4 minus 5i. Okay, and that will be equal to 2 times 4, that's 8. 2 times minus 5, that's minus 10i. Okay, again, this one, 3 minus 3i times 4, that's minus 12i. And finally, minus 3 times this one, minus 5i, that's plus 15i squared. Minus 3 times minus 5, that's plus 15, and then I times I, that's I squared. So that gives us 8 minus 10 minus 12, that's minus 22i. Okay, and then plus, this will be minus 15. This one will be minus 15. So that's giving us 7, 8 minus 15, that's 7 minus what? Minus 22, 22i. So that's the first one. Then we'll now go on and multiply our answer with a 7 minus 22i times the last one, 1 plus 3i. Okay, you multiply the first two. So whatever you get, you now use it to multiply the third one. And that will be equal to 7 times 1, that's 7. 7 times 3i, that's a plus 21i. And then 22 times 1 minus 22 times 1, that's 22 minus 22i. And then minus times the plus, that's minus 22 times the 3, that's 66i squared. Okay, and that will be equal to yes, minus times plus, that's minus 22 times 3, that's 66i squared. So we now have 7. This one will be plus 66. Okay, the I squared is minus 1, so making this one to be plus. So plus 2 minus 22, that's what? That's minus 20i. So we're having 73 minus 20i for that place, for this live section. I cube be equal to I squared times what? Another I. And don't forget, I squared is what? Is minus 1 times what? Times I. And that's giving us what? Minus what? Minus I. Okay. I've explained that the root of minus 1, when we are young, we always say it is impossible. But advanced class, root of minus 1 is what? Is I. Okay. Then you can square this place. You can square this one also. So the moment you square this one, the square root will disappear, and you have what? Minus 1 equal to what? Equal to I squared. So I squared is equal to what? Is equal to minus 1. Let's go to the B part. I to power 4. I to power 4 will be equal to I squared and then I squared. Okay, we're going to split into two parts. Split into two parts. This one split into two parts. And that'll be minus 1 times what? Times minus 1. And that's plus 1, or you say 1. Okay? And the final one, 2i 2i to power 3 implies 2 to power 3 times what? I to power 3. Okay, and that will be 8 times what? This I cube, we've gotten the value as what? As minus I, and that will be minus 8i. So the next thing we want to look into now is the conjugates of a complex number and rationalizing denominator. Complex conjugates and rationalization of a denominator. What is the meaning of a conjugate? A conjugate is very simple. If your complex number z1 is this, a plus bi. Okay, the conjugates, this is your real part. The one with the I is the imaginary part. Okay, so the conjugate is what? Is for you to go to your sign that connect the real part and the imaginary parts and reverse, alternate the sign, and that will be what? Z1 conjugates will be equal to what? Which we use as an asterisk, will be equal to A minus B I. We just alternate the sign, just change the sign. That's the meaning of the conjugates. Change the sign that connects the real parts and the imaginary parts. Change the sign. If it's minus, it becomes plus. If it's plus, it becomes negative. Let's see the solution to this one. I'll just take two of them. The first one, 2 plus 3i. The conjugate will be equal to what? We can call this one, let this one be what? Z. Okay, so Z, the conjugate of that will be equal to what? 2 minus what? 2 minus 3i. The B part, let's call it also Z. Okay, we can call it Z2, 3 minus 2i. The conjugates is what? Is just change this sign. That will be 3 plus 2i. The third one, let's call it Z3, which is root 3 plus I. So its conjugates, okay, will be equal to what? Root 3 minus I. Just change the sign, okay? This one also, do the same thing also, just reverse the sign. We are told to find Z plus its conjugates and Z times its conjugates. So given that Z Z equal to 3 plus 5i. Okay, so for the first one, let's see solution to that. As you are coming in, just begin to say add and begin to like, share, and subscribe to the channel. Like, share, and subscribe. The first one, we have Z as 3 plus 5i. Okay, let's get its conjugates, which is Z asterisk. Okay, equal to 3 minus the sign here will change. We have this. Then you can do the addition of the complex number and its conjugates and that will be equal to the real parts. Okay, let's write this Z1 plus what? Z2. Okay, the real parts plus itself, real parts plus this, that's 6, 3 plus 3, and then 5, this one, and this one we cancel. Okay, so that's 6. Can we do for number 1, let's do the multiplication. Z times its conjugates. Z times its conjugates. That will be equal to what? 3 plus 5i times its conjugates. So which is this. Okay, and if you do the multiplication, this is the difference of 2 squared. There's no need to bother yourself, and that will be equal to what? 3 squared and then minus 5i squared. Okay, if you use an entity that says that A plus B times A minus B. Once the expressions are the same and they're having alternating sign, it's going to be the first one you square that, and then minus will follow times the second times the minus the second part, square of the second part. And that's what I apply in this place. That will be equal to what? 9. This will be 25. I square is minus 1. That's a plus 25. Okay, and that's giving us 34 for the multiplication. Okay, and if you like, do the number expansion, you get the same thing. Let's do the B part. I'm going to leave the B part for you. Let's see your answer in the comment section to do the addition with its conjugates and to do the multiplication with its conjugates. So I'll go to the third part. The third part, Z is 2 root 2 plus I root 2. Let's get its conjugates, and that will be what? 2 root 2 minus what? Minus I root 2. Can we add them together? Do the addition of the conjugates and the complex number. So this one plus this one, that's a 4 root 2. Okay, and this one we cancel, we disappear. So we have this. Okay, let's quickly do the multiplications of the complex number and its conjugates. The complex number and its conjugates, that will be 2 root 2 plus this times 2 root 2 minus I root 2. So this will be equal to what? Apply difference of 2 squared. That will be 2 root 2 squared. Okay, the same expression but alternating sign. So minus I root 2 squared. So this will give us what? This square we affect this one. That will be 4. That's 2 squared. And when you square square roots, it's going to disappear. Okay, it's going to vanish. So that will be what? Times 2 minus this one will be I squared. The 2 will affect this, and we also affect the square roots. That will what? That will be times 2. So that will be 8 I squared is minus 1. Turning this one to plus times 2. Okay, so the answer is what? The answer is 10. So that's that for the complex number times its conjugates. Complex number times its conjugates. Don't forget to subscribe to the channel so as to keep track of the update of this channel. Like, share, subscribe. As you are coming in, just say hi or say good evening, good afternoon, wherever you find yourself across the globe. Okay, let's look at the divisions of two. Yeah, for divisions of two complex number, this is what we have. This is a question. Let's see solution to the question. Simplify 10 plus 5i divided by 1 plus 2i. So this is what we have. Okay, this is a two complex number. When you are dividing two complex number, step one is to multiply the given problem by the conjugate of the denominator. Okay, multiply by the what? The conjugate of the denominator, both the top and the bottom. What are we saying? It's very simple. Step one, get the conjugates. And the conjugates of the minus 2i. Get the conjugates. Okay? And use the conjugates to multiply the numerator and the denominator. And that's what we have done here. Then after that, begin to do the algebra. Okay, do the expansion, and that will be equal to what? That will be equal to this one times this one. We're going to have 1 times 1 minus 2i plus 5i times 1 minus 2i over this one. The denominator is a difference of 2 squared, which will be 1 squared minus 2i squared. Okay, So that's that. If you open these brackets, that'll be 1 minus 2i, 5i times 1, that's a plus 5i, and then plus 5i times minus 2i, that's a minus 10i squared over 1 minus 4i squared. Okay, so we're going to have this one is equal to minus 1. I squared is minus 1. So we're having 1, to change this one to plus, that's 1 plus 10. Okay, 1 plus 10. And this one, that will be plus 3i over 5. Here also, this is also minus 1, making it to be plus 1 plus 5. So we are having 11 plus that 3i over 5. So that is the answer for that case, which we can also write as 1 over 5 times 11 plus 3i. Okay, and if you open the brackets, it's going to give you 11 over 5 for the real part plus 3 over 5 for the imaginary parts. And that's that on that on this episode complex number 1. Okay, if I want to say, if you're yet to subscribe, please do so now. I want to thank you for coming on board. Thanks for sharing. If you're yet to share, if you're yet to subscribe, okay, if you're yet to like the video, begin to do that right now. At this point, we'll drop the curtain of this lecture for today. See you tomorrow. Bye bye.